Welcome to Mastering Innovation Together with Kevin Mobley of the Ian Thomas Group and Chris Koomey of Thorben Consulting. So welcome, Kevin, and you've been innovating your whole career. And I know it started with Ian Thomas Group. So tell me a little bit about what Ian Thomas Group focuses on and how you got started down that innovation pathway.
Sure. We focus on software performance engineering and cybersecurity. Obviously, everyone knows what cyber is about, but software performance engineering is the issues that happen with healthcare.gov. How do you make sure that websites, applications, basically anything that's software-based performs and is reliable and stands up? So we rewrite a lot of code. We do a lot of architecture work to make sure the systems themselves actually will scale and perform to meet millions, and in some cases, hundreds of millions and billions of users and interactions.
And let's be clear, you weren't involved with healthcare.gov.
No.
But the reason why you do software performance engineering is so you don't have problems like that.
No, we weren't directly involved with healthcare.gov at all. In fact, but I did meet with the guys after the fact that were responsible for saving healthcare.gov, and the kinds of issues that they were running into is the exact same kind of problems that we fixed at a bunch of Fortune 500 companies. In fact, at the same time the healthcare.gov was going on, we were working on a similar problem at a top 10 bank, where their entire retail operations was unavailable. So you can imagine it's payroll time. You go in on a Friday expecting to get to either deposit a check or withdraw some money or get access to money to pay your mortgage. And they say, well, I'm sorry, sir or ma'am, your account's not available. And it's because our systems are down. And so they can't tell you whether you have, $5 in your account or $500,000 in your account. And it was creating all kinds of obviously customer issues at that point. It was creating out of balancing issues for the bank. The bank was running about $25 million a day out of balance, which is something that banks you just don't happen in a bank. The feds made the bank put aside $1 billion because they didn't know what the cash position of the bank was. And we went in and we fixed the problem. It was a series of issues. One of the major problems was what we call a one-lane bridge, where you have a point in the software where every transaction has to go through and they're serialized. No transaction can happen before the next. And there were certain transactions, especially administrative in nature, that were taking long periods of time. And that was causing the system to think that the network connection had been cut to the branches. And then the bank would go into what they call local mode, or into a state where, hey, if a backhaul comes through and cuts the connection to the branch, they need to still be able to operate. That was designed as if you would be down for days. But because of the nature of the way this one-lane bridge was working, you'd have systems down for a few minutes, come back up, down for a few minutes, come back up. And it was causing duplicate transactions to go up on the system. And that was causing the out of balancing issues. And it was just going on and on and on. And there was huge customer impact. And so that was a major architecture issue. And I highlight that because oftentimes when people talk about software performance engineering, they think of the simplicity of load testing. They think of it as, hey, we just simply hammer the site with tons of load, and then we look to see how the system performs. And that's a very crude way, a sort of rudimentary tool that's used in the space. But the essence is how do you design for the outcome you're looking for? And so the parallels on the cyber side is the equivalent of saying that, hey, I'm just going to emulate a bunch of hackers and pretend that I can break in your system. And if I can't break in your system, somehow your system is secure. And when we all know that's not remotely how you secure a system, you have to think about cyber as a holistic problem from, hey, what are the crown jewels of the system of our enterprise? How do we make sure that we can recover when those crown jewels are stolen? Because more than likely they will be at some point compromised. And then think through from that perspective backwards into what particular technologies do you leverage? Well, how do you, structure your staff? What type of insurances do you put in play? Just thinking of cyber in that holistic way. And that's the way we approach performance and cyber.
And back in the 90s, when you started, it was a little more kind of rough around the edges, but now things have gotten a lot more sophisticated, particularly as things move to the cloud. So with the cloud, are you using some of the automations that are available as you implement your software performance engineering?
Yeah, I mean, one of my favorite examples is actually not some work that we do directly, but it's a company that we all know and love, which is Netflix. So, Netflix is a company that's so incredibly large that there's no way that they can basically, in the old days, load test for 200 million customers, 200 million households. And so they roll out changes all the time. and they've built this incredibly sophisticated leveraging of the cloud. In fact, they're probably, even today, probably the most sophisticated I'm aware of, in how they use the cloud, how they use the infrastructure to basically roll out changes and basically use their customer base as their load testers. But they've got the instrumentation in their application in a way that they can tell immediately there's a problem. And as soon as there's a problem, they can roll back those changes. And so they roll it out in stages, and it just works beautifully. The amount of downtime and customer impact is remarkably low, considering not only the number of folks that are hitting the system, but the diversity of endpoints that are hitting the system, the sheer global nature of their enterprise, and just the complexity of what they're up to. I mean, they're one of the largest cloud infrastructures in the world, if not the largest. At one time, they were the largest. So it's just an example of thinking about performance from the front end versus reacting to it from the back end.
And part of it is just the reality is that we expect things to work now.
Yep.
And we're kind of spoiled because things do work because of some of these activities that are happening behind the scenes, where 20 years ago, things got hung up all the time.
Yeah, absolutely. And we weren't as dependent. I mean, we think about ourselves as having had computing around a long time, but computing 20 years ago was still an office activity. You had a computer at home that you used for some simplistic tasks, but it wasn't integrated into your life the way it is today. And you think about driving a car and the fact that the computer's doing the driving, and soon the computers will be talking, two cars will be talking to one another and negotiating. You think about the issues going on with airlines. I mean, we all know that there's a major airline in the news right now because of all their antiquated systems. And not being able to basically fail over and recover and get back online. That's just an example of not thinking about technology as integrating your life. Not the particular airlines in the news right now, but I'll give you a quick story that kind of wraps a little bit of cyber and a little bit of performance into the mix. I was meeting with another major airline that we had done some work with, and they were bragging about their future use of biometrics. And so as they talked about how it was going to make passenger travel so much easier on the airline and what have you, my questions went immediately to reliability and security. Who's going to own that particular information? What happens to the information when that information gets compromised? And of course, how do the systems themselves perform in a way that, hey, if I walk up and scan my retina and I get used to that, and I'm no longer, the airline itself is no longer set up from a workflow standpoint to do what it does today. How do you prevent that system from failing and not allowing passengers on the plane? We actually worked for that airline when they actually had a major disruption of their systems that allowed you to get on a plane, and it took out all 3,600 operations around the world. So it's no question that technology today is more integrated in our life. It's becoming more integrated in our home life. It's more integrated in our healthcare. It's more integrated in our transportation systems, and we rely on it in a way that we just didn't 20 years ago.
And thank you, Kevin, for sharing some of this and how you're helping us master innovation together today. Thank you for mastering innovation together today with Thorben Consulting. This is Chris Koomey. We'd love to hear from you. If you enjoy the show, if you have any comments, questions, or just want to learn more about what we do. Thanks for joining us.